hitting, oh, just perfectly right there. It's just where it stopped and how I had everything angled, you know, just perfect. Everything was perfect. And I dumped like 75 gallons of coolant onto the floor because I was gone. Have you ever been puzzled and perplexed about a build so much that you're pissed off? Well, you're in luck, because today I've got a mystery on my hands and we're going to try to solve it together. So I got this VRD Carbon. It's been ready to crawl now for about a week or so, and I installed a servo. Servo didn't work. You know, maybe just a bad one out of the package. Installed another servo. Servo didn't work. Maybe two servos bad out of the package. That's really not likely. So right now, let me just show you what we would do. We're gonna start troubleshooting. Let me throw a servo horn. I think I tossed one into my bin down here. Or did I? No, where did I put it? I threw it away, didn't I? Oh well, we'll go on without it. We can hear if it's working or not. Yes, a piece of tape. It's just something to show what is happening. All right, which one am I gonna put in there? Probably the SHV650, because it is a badass. Sorry kids if you're watching. Are we PG-13 now? All right, so, you know, we should probably unplug this first. There we go. We are going to put our power, and then we put our signal, channel 1. There we go. Now we're going to plug it back together. All right, we're armed. It works, right? Okay, we got that. Yeah. Servo does nothing. What if we change the channels? It could be the channel in the radio. That could be it. All right, just tell me no signal, right? Yeah. That's cool. Plug it into channel 2. Nothing. All right. So it's probably not the signal. I mean, it worked fine. Okay, let's try it even the other way around. We're going to put our ESC into channel 1. Okay, it's not working on the steering. This is a new radio that I've never tried. So, okay, it did arm, I think. Let's try it again. It did arm. We'll reset it. Could it be the radio? Or maybe our radio dual rates are turned down so much it will do nothing. Let's try. Woo, hey, dual rates. All right, we're gonna go back. We're going to put the steering back into channel 1. Is the dual rates. Interesting. All right, so how much? So we're still not getting a lot. Didn't expect that. We're still not getting a lot of steering. It's like 90 degrees. I want to say this one was more than a 90-degree servo, but hey, that was simple. I am glad that was simple. That's I had tested the continuity or the voltage coming out of this and it was showing me 0. I'd probably unplugged it. So that was going to be the next test, is continuity from there. And then, you know, once you, I mean, if there was no continuity, then of course there would be a problem. But geez, I feel silly, is what I feel. But hey, there we go. We're at least somewhat along the way. Now I do wonder, with this radio, we'll see how much steering throw that I get with a Vanquish steering arm on there. I do wonder if it's going to be enough. So hey, let's just go ahead and install it. I think we figured that out quickly enough. We're going to undo these. Give me a little bit of room to work, but hey, we're getting closer. Neat. That also seemed to be really slow. Normally these are extremely fast. So I'm probably going to switch out this radio for one that is known. Okay, which way does our servo horn need to be? It's going to be on this side. And where am I gonna wire this? Somewhere through the chassis. I'm happy. I'm not totally happy, but I'm happy. That was simpler than I thought that it might be. Now, I've been told that when I stop talking that y'all can hear everything in the room. Y'all can hear the crickets underneath the house, which this is a 4-foot thick concrete pad. There's no crickets underneath, I can tell you that. There is foam, actually. This entire building has a 4-inch slab with 18 inches of foam on the inside, and then like concrete piers that run up and down. The only reason why I know this is when I got the big old CNC machine, the Mazak 250 MSY, I was drilling in and I was expecting, you know, concrete all the way down, and they had special anchors that I had bought, a bunch of these special anchors, and we had determined the length of the anchors based on what we thought was the depth of our concrete slab, which at least, you know, if we looked on the outside, the top pour it's like 12 inches or 16 or something like that. So I had based all the calculations and all the parts that I bought off of that. And then I went to drill the first hole into it and it broke through at 4 inches. It's like, oh no, like this is not what we bargained for. And besides that, a 4-inch slab, yeah, when you're putting a, how many ton machine was it? It's like 12,000 to 15,000 pound machine plus all the things around it. 4-inch slab's not that thick. And so I called the company that did the footings and had sold me essentially these bars that you epoxy into the floor. And I was like, hey man, I think I'm gonna have a problem with this thing. You know, it's not gonna be anchored properly. It's gonna move all around. We've got a bar feeder. You can't have a machine and a bar feeder not anchored because they, like, you know, they shimmy around and then your bar feeder gets jammed, or, you know, there's all kinds of bad problems at any rate. And the first thing that he said was, you ever had any forklifts on your floor? Yeah, actually, all the time. In and out. They actually pulled it in here. Let's see. It's a multi-ton forklift. At any rate, you know, this has been a meat packing facility and they use forklifts in here. And he's like, all right then, any cracks in the floor? No, actually, no cracks that I've seen. He's like, yeah, it's probably really good concrete. If there's no cracks in the floor right now, you're probably fine. And then he followed it up with, I'll never forget, remember, these machines are installed in Navy boats. And Navy boats are a big, flexy, just, you know, it's a big thing of steel. And even though they're anchored into the floor so they don't slide around, you can imagine if a boat started to capsize, you don't want a 12,000 to 15,000 pound machine sliding around in your machining room. So they're all attached into the floor, but the entire thing is flexible. So you can imagine that your concrete pad it's like a wave, and when your machine reverses direction or has these big rapids where we're literally moving thousands of pounds around back and forth in rapid succession, you think of it like a wave. So it's going to move this way, it's going to stop, and that wave is going to transfer all the way through your concrete pad and out to the edge of the building, basically. Which, interestingly enough, once we were running, you could hear it running outside of the building because it did transfer all the way through. And every little, like, zing, 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 as it was doing a machining pass over and over, you would hear it on the edges really loud, like you were standing right next to the machine. You know, so the guys that work in the building that's behind us, the different building behind us, if we were running something with a really interesting machining path, they would tell me when I got over there. It's like, what are you making over there? Like, we can hear every single cut. When they're, you know, playing in the yard, the yard. It ain't prison back there, but I guess it's close enough. So, yeah, at any rate, it worked out just fine. And the 4-inch concrete pad, which is filled with foam underneath, because this was a meat packing facility, never had a problem with it. And as long as we don't open up the doors, it's actually a very insulated building, very well insulated. It's 8-inch foam on all the walls. The ceiling is like 8-inch foam or something like that. And then we have, you know, a foot plus of insulation on the inside. So that was just kind of a fun thing to learn and deal with, of course. That's not what I expected for the machine install, but that's what we got. It was a lot of fun. All right, I don't really know which way to put this receiver wire here. Like, which way should it go? I don't want it getting into the gears, so I guess backwards. I should probably update my stuff. So I think I've been getting smart enough to keep my zip ties in this drawer. I think. There's a lot of stuff in the drawer now. Yeah. Got it. Oh yeah, I got to keep talking so we don't hear the crickets underneath the floor. All right, what's another story I can tell you about? Let's see. Let's talk about when I used to make lockers on this big old fancy machine. So one of the things that I ran was lockers for the old SCX10 style axles. A relatively popular product there. And when I first got the machine, it's just barely not. Oh, it'll go through. It'll go through. When I first got the machine, and actually I had some engineers come in and help me get it running for those initial products. You know, they taught me how to program the machine essentially. I was running conversational, not cam. So they came in and we set it up and we had everything, and each one was about 7.5 minutes a piece. Cycle time, you know, from the door opening and closing and spitting out a new one every time, 7.5 minutes. And that was pretty good. The machine was making about $2 a minute, which was barely enough to pay for it because we had a very fancy new machine with a fancy new loan, of course. But $2 a minute on a machine is still really good, right? And so that was what we based all the costs off of, and it was just enough money for the machining company to sell it to Holmes Hobbies and a few other companies that were contracting us to make these and pay for our overhead. Now that didn't include having employees or anything because I was running the machine myself. And being a machinist is a completely different skill set than what I was used to, right? You're not only having to make something, so we've got a design, and the design has to be manufactured. So design for manufacture is a specific skill set that a lot of engineers don't have, I learned over the years. So I had to learn how to design for manufacture, and then I had to learn how to manufacture them. It was trial by fire, because again, I had a big fancy payment coming up, and that was pretty much our option. You run it or you die. So over the years, 2.5 years that I had the machine, it wasn't very long in the grand scheme of things, I had learned how to whittle down on that machining process. Just this one in particular as an example, I whittled it down from 7.5 minutes to 3.5 minutes. But of course, we didn't change our prices on anything. This was just me being a more effective machinist. And on top of that, the one tool that was, you know, the worst as far as wear was our 1/8" end mills. And since we were cutting in steel, these were 4 flute. They were coated, relatively expensive at the time. I think I'd found a place that would sell them, Enco, I forget which. I'd have to look at the catalog. One of them is a crappy tool company, and the other one is a really nice tool company. You know, we were paying, gosh, it was like $13 a piece at the time for them, which is a good deal. Now they're, you know, $25 a piece or more. And so that tool in itself was the majority of our costs. And I started out with this. Let's see, there's the hole. I started out with this, and I was getting maybe 2 hours of machine time for them. And at 7.5 minutes a piece, you can do the math at how long that is. It's not very many, so we were depreciating quite a few pennies of tooling cost into each one. And you know, so essentially I was kind of losing money at first running the machine because I didn't know what I was really doing, and had just guessed on pricing. So this, you know, again, trial by fire. I'm learning how to be a machinist while I am being a machinist. It was pretty much my only option. Right, I'm having to move this zip tie because it's pressing into the battery, and I don't want that to dent a cell. All right, so continuing with the story. Yeah, 4 flute end mills, that's right. That's where I'm at in the story. I'd gotten 120 minutes machine time, and then they would start to chip and break. And if that happened, then you know the part's toast. If you can't insert your outer shaft in, you know, it's not a good locker, right? And over those years, I learned all the little secrets. And one of them, which was probably my biggest increase in speed on all of this, was that instead of using the end mill to essentially slot down the hole, because that was, you know, at first that was our only option because I didn't have enough live tool holders for other things. I learned that we could pre-drill the hole with an 1/8 inch, and then we would do a fast plunge and then and cut those walls out. When I did that, not only did we, you know, gain like 30 seconds of machine time, even though there was one more tool change, which tool changes in them in itself was a big time burner. You want to avoid all tool changes, essentially. We went from 120 minutes per, because we were doing a ramp cut with the end mill all the way down. So 120 minutes per end mill, and at the end of it, I was replacing them at 600 minutes. So 10 hours in the cut. 10 hours for these end mills. And I was replacing them just knowing that I didn't want one to break, because if one breaks and you don't catch it, then you know you can make 10 lockers or whatever in a really short period of time, and you don't catch them being bad, and then you know that's a bunch of materials wasted as well. Now if you have another op, like let's say that this caused other problems, you know, we have the pre-drill, we have the end mill going down. If your drill breaks first, and we also had a spot drill to make sure that that didn't wander, but if your drill breaks, or it's, you know, drilling poorly in a sense, then your end mill breaks as well. So there was just so much to account for until you would get the processes set to where you knew your tool times, you knew how long each tool would go before you need to replace it, so that you could catch a tool breakage before it happened. You know, what a great experience though for learning how to design to manufacture. There's no other way, in my opinion, than just literally learning how to manufacture them. That's the whole deal right there. You learn how to manufacture them, you're learning how to design for manufacture. So probably the very best that I could have done for myself as a designer of parts was to have this big, fancy, expensive machine and require myself to learn. That was what happened. So at any rate, yeah, the pre-drilling saved a whole bunch of time. It was one extra tool change. It was one extra tool to have inside the machine. So there were positives and negatives to it, but it increased our machining time greatly. And I actually learned that of all the drills that I tried, the DeWalt high-speed steel ones had the best reliability. And you know, you couldn't push them really hard. You couldn't push them as hard as a solid carbide, but the solid carbide would chip, and then you would have oversized or undersized hole, usually undersized, and then I would end up chipping the tips of our end mill instead. And that's, you know, that just increases your likelihood of having other failures in the machine, and you know, it doesn't make the slot the right width, and A leads to B and B leads to C when you're machining stuff. So yeah, that was probably one of the more fun portions, in my opinion, of doing all of this. Was, you know, I got to really hone in, almost cut the machining time in half, which at the end of it, I was tired of chasing jobs, and I really needed to focus back on Holmes Hobbies instead of Holmes Motion Control. So that was really the reason why I sold the machine. I was still paying for it and everything, and I could have kept it, and then at the end of, you know, the original plan was to have that machine paid off at the end and then step up to the next size bigger machine, or go to a vertical milling center or horizontal milling center or something like that. Never got there. Ended up burning myself out to the point where I was like, no, I'm not going to continue this line of work for myself. And I still have machines, but ones without payments, so that I don't have to run them. If I don't want to run them, I don't have to run them. So that's kind of a, you know, live and learn. This is what we should do, is we live and learn. And sometimes we go from one thing to another. We go from one industry to another. And I've been talking so much that now my voice is hoarse. But I hope you enjoyed that little story about the trials and tribulations of being a machinist and the fun things. Yeah, so I guess to pull this all together, that end mill, that particular end mill operation, especially at the end, when we had the pre-drill, instead of it being a kind of a gentle just as it would go down, with that pre-drill, now we were just kissing the sides of the hole back and forth to make a slot, and it would go and you could hear it as it got deeper and deeper. It kind of like changed tones a little bit because you're technically engaging more and more of that tool length as you go down. So it had the coolest sound, and it would, you know, go back and forth 12 times or whatever my depth of cut was set at for the depth of the slot. And you could always tell when it was in that one portion of the cut. And for, you know, we would have front side and back side tooling doing the same operation. And I could always tell where it was within that machine, you know, making that one part, just because of the sound of it, which was really cool. So I always knew when it was on the back side and that was the final operation, you'd hear it, and it hit that last one, and you'd hear that whoosh of the sub spindle moving and the bucket opening and then dropping the part in, and it's like, hey, you know, time for me to go, you know, gather 10 parts out or whatever, or, you know, check my tool lives, or you know, whatever the case would be, depending on how long it was. I did get to the point to where I was able to pretty much run a full bar at a time. I never got the bar feeder going because it was just so much of a risk being able to like walk away. I tried walking away and like going to a bar once, and I came back, and only time this ever happened, there was one time that this happened where the machine got to the end of the bar and it had done what I told it to do, you know, repeat 24 times or whatever for the bar and then cut off. I think it's more like 40 something on a bar. And at the end, the entire machine shuts down. Every time, it always shuts down. And this one time, there was some fluke, and the coolant didn't stop running. And just where the spindle stopped and where the bar stopped, the bar just barely came out of the throat of the machine. So, you know, you've got this little 1-inch hole, and the bar comes out of the hole, and you can see down it, right? You can just barely see down this hole. Well, the coolant didn't shut off for whatever reason. Again, the only time it ever did this in the entire operation of this machine. So we have straight high pressure coolant hitting, oh, just perfectly right there. It's just where it stopped and how I had everything angled, you know, just perfect. Everything was perfect. And I dumped like 75 gallons of coolant onto the floor because I was gone for 30 minutes after that bar stopped. And then, you know, I get to come in with my squeegee because, you know, there's always coolant on the floor. Unfortunately, there was you know, holes in the floor, drains, so it didn't, you know, escape into all edges of the building. But yeah, live and learn. All right, so the last thing that I got to do on here is bolt up my steering arm, whatever, our servo thing. I can't think of words right now. Horn, servo horn. Oh, we should have let people in the comments figure it out for me. Put down below what that thing is called that I can't remember now. So yeah, we bolt that on. We're going to be good to go and crawling. I mean, we've already spent so much time already that I should probably cut it short because the algorithm doesn't like videos longer than 12 minutes, and I know that I probably ranted for more than that. But y'all have seen me bolt on a servo horn before. I don't believe that you're going to be missing out. But look what I did to the wires. Have you ever seen me clean up the wires on a rig before? No, you haven't. You haven't. I am pretty sure that I'm not going to be switching out these electronics. I say that, and I already know that there was a prototype that I should have put in here to test. Whatever. But, ooh, yeah, look at that. This battery now sits flush and flat. And then we can plug it in, make sure our radio's on and works, and our dual rates are turned up, of course. Yep, there we go. We are almost ready to ride. Well, if you have any questions about being a machinist and the ups and downs of that as a trade and the ability to squander $20,000 in the course of 5 seconds when you press the wrong button, let me know in the comments, and I will do my best to get to them without reliving all the perils of being a machinist. So there you go. VRD Carbon is ready for crawling. I'm excited to get out there, and unfortunately it's super cold outside. So I'm gonna have to figure out what we're gonna do on that for the cameras and everything, because they don't like the cold so much. And then we bring them back in and there's humidity on the lenses, and getting off into the weeds here again. Thanks for tuning in. Have a great day.